Hello everyone. Interview namin Lately Christie Gloria Tampi from Information System, Faculty of Mathematics and Natural Science, University Sam Ratulangi. Here I will read about my journal with the topic of graph coloring. So in this journal, starting from abstract, introduction, literature review, application, discussions, and conclusions. So, uh, graph theory is a branch of mathematics that studies the structure and properties of graph. Graph theory is an important tool in graph theory that involves assigning colors to the vertices of or edges of a graph with a certain constraints. The goal is to avoid conflict and optimize resource allocation. Determining the number of polychromatic is an NP-hard problem and also heuristic and meta-heuristic algorithm, and can provide good coloring. They do not guarantee an optimal solution. Future research focus on developing more effective algorithms and exploring specialized graph consists of practices P and HSA graph coloring aims to assign colors to practices or H without any two advanced elements sharing the same colors. Practice coloring is one of the main problems in graph coloring. The goal is to assign a different color to each agent in a graph in a way that minimizes the number of color used. Formally given a graph B, G, A, B is the type of vertex and P is the type of edge. Vertex coloring is a mapping function C, P to C, which assigns a specific means P color uh, uh, a color C element C such that for H and U V element P C U C the chromatic number 8 of a graph G is the minimum number of colors referred to color the vertex of the graph. The first coloring the first coloring minimization problem focused on using the smallest possible number of colors to color the vertex in a graph, while ensuring that adjacent vertices have different colors. The minimum number of colors required for correct vertex coloring is called the chromatic number and is denoted by Xg. The vertex coloring minimization problem has many practical applications because the use of paper colors often correlates with better resource management, cost reduction of efficiency improvement. For example, uh, in scheduling problems, minimizing the number of colors or time slots can result in a more complex schedule, where in frequency assignment problem, it can maximize the number of available channels. Approach to solving the vertex coloring minimization problem is exact algorithm. Algorithms such as branch and bone and intelligent programming can find the optimal solution, but are usually only practical for small or medium graph. Through approximation algorithm. Thus, those algorithms provide solutions that are grounded to be within certain factor of the optimal solution, certifying optimality for computational efficiency. And three, heuristic and meta-heuristic. This approach such a greedy algorithm, local search, genetic algorithm, and colony optimization and to find high quality solutions efficiently, albeit without granting of optimality. The solution of a depends on factors such as the size and complexity of the graph. A fiber computational resource and the balance between solution quality and computation time. Graph coloring goes beyond theoretical interest and finds practical application in various domains. First, register allocation in computer science. During program computation, graph coloring helps assign register variables to avoid uh, conflicts during execution. When variables are used simultaneously in a program, they cannot be assigned the same register. Graph coloring helps identify registers for a variable such that no conflicts variables share the same register. Two is scheduling. Scheduling tasks or resource can be modeled as a graph coloring problem. Tasks are represented as certificates and conflicts between tasks requiring the same resource are represented by eight. Graph coloring algorithms can be used to create efficient schedules that avoid resource clashes. And three, map coloring. The classic example of coloring adjacent countries on a map without any clue sharing the same color demonstrates the practical application of graph coloring in a real-world scenario. The four color theorems though not directly applicable to real-world maps too. Practical consideration and challenge in a real-world application, applying graph coloring technique to the real world. The the real world, a problem often involves overcoming practical challenge, including integration with existing system and ensuring complete compatibility. Comparison with other optimization techniques, graph coloring over is offers a unique purpose perspective on optimization problem by focusing on assigning labels or results to variables or s according to certain constraints. This approach can be more intuitive and easier to model for some kinds of problems, especially those involving spatial or temporal relationship, future research direction, and open problems. Um, because on developing more efficient and effective algorithms, especially for NP-hard test exploration of structural properties of certain classes of graph and encapsulation of these properties to design specialist algorithms can improve performance for certain problems domains. Ada comparison with other optimization techniques. Graph coloring offers a unique perspective on optimization problem by focusing on assigning labels or resort to vertices or edges according to certain constraints. This approach can be more intuitive and easy to model for some types of problems, especially those involving spatial, or temporal relationship. Future research. Future research focusing graph coloring is an important area in graph theory with many practical applications, including scheduling, research allocation, and conflict of However, computing the polychromatic number of a graph to determine the best coloring is a computationally and hard task. Com- Complexity and approach Complexity and approach to this complexity research have focusing on the following or effective heuristic approximation and methodistic algorithms to find high quality coloring in reasonable time. These approach do not guarantee an optimal solution but can provide the result with better computation efficiency. Okay, so this is my journal with topic coloring graph. Thank you.